In this video, I'll talk through Theorem 2.35, which is De Morgan's laws. This time for sets. But we should be able to recognize De Morgan's laws of logic as we work to show that these are true for sets. So, right, before you watch this video, you should already understand what a complement of a set is, right? So given a universal set and a set A inside of that, the complement is everything that's not in A. So De Morgan's law is saying if we have two sets, we take their union and then take a complement, that's the same thing as taking the intersection of their respective complements. So let's illustrate this first of De Morgan's laws to get a sense of why it's true. So A union B complement. So A union B is everything that's in A or in B. So it's everything that's in both of these circles. So A union B complement is everything outside of both of the circles. So I'll use blue for this. So it's all of this stuff. Everything in the universal set that's not in either A or B. So that's A union B complement. Now at the same time, we can take A complement. So that would be everything outside of A. Sorry, a little bit of the line went into A there. So I'm going to try and get rid of that. There we go. Notice there's some stuff that's in B because there's some parts of B that are not in A. So this whole shaded region there is A complement. We can also take B complement, so everything that's outside of B, but in the universal set. And that would be this stuff. And then we can take their intersection. So I want all of the stuff that's in both A complement, everything shaded up here, and in B complement, everything that's shaded there. So what's common between these? You might have to stare at this one for a little bit longer, but notice that it's just everything outside of A union B. That it's exactly what I drew over on the left there. That A complement intersect B complement is all of this stuff. And so those two are the same. That's an idea of why they're the same, how that works out. Let's actually prove this first. Let's just prove the first of De Morgan's laws. So remember in the last video, in order to show that two sets are equal, I can show that, right, I have subsets in both directions. I could also just show that being a member of this set is equivalent to being a member of that set. That's more like how we showed two sets were equal in the first couple videos. So I'm going to use that again. That'll work well for this one. So I'll say here proof of 1. So what I'll do is I'll write out what it means to be a member of A union B complement. So X is in A union B complement. This is equivalent to being X is not in A union B, right? That's what complement means, is not in A union B. In other words, this is the same thing as saying not X is in A union B. So that's definition of complement. I could write it either of these two ways. These are equivalent. That's really, anytime we do a strike through, it's the same as doing this negation of the connective. And now I'm going to break down A union B, right? So we know that this is equivalent to, so I still carry the not, X is in A or X is in B. And now I can use, so that was definition of union, now I can use De Morgan's laws of logic to bring this negation through. And remember how that works, oh, I forgot to write my inclusion here. Remember how that works is I negate each part of it and flip the or to an and. So this is not X is in A, and maybe I should put another that around it, and not X is in B. So what does that mean? That means that X is not in A, and not in A, and X is not in B. And now building back up into sets, I have the and operation between these two. And so that means, or rather, what do I want to say here? I want to say that this means X is in A complement. So X is in A complement, and X is in B complement. And so X is in the intersection of A complement and B complement. A complement intersect B complement. So that's the idea. You should be able to run through now the proof of 2. Think about that on your own, and run through a proof of why that's true. Again, it's going to come down to one of De Morgan's laws. So it should be very similar to this. I'll let you do that on your own. All right, see you next time.